Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the analog input module of PLC S7-200 model EM235 connect with the thermocouple. Okay. So here is the example of wiring between thermocouple and transmitter and isolator connect with the analog module. So I would like to explain for detail about how to wiring and why we use the isolator. Yes. So here is the CPU. So we just supply the 220 volt AC to here. We will got the 20 volt DC from this terminal, and then we can connect to the EM module for supply the power to EM module. Let's see here, when we supply 24 voltage, it will show green on LED for 24 volt DC. Okay. And here is the temperature transmitter. That rank specification we can increase to another rank, so we can configure inside here. Yeah. So right now I will use rank from 0 to 100 degrees Celsius, and the output is 4 to 20 milliamp. Okay. And here is the thermocouple that I will use 2 wire. Yeah. Connect from the thermocouple. It is the minus and it's the plus because it is the millivolt, right? For signal from thermocouple. And then I will use the terminal plus and minus connect to the isolator. Yes. And then it will provide 4 to 20 milliamp here. I will detail on the drawing of this one. Yes. So if we not use the isolator, the signal will not smooth because here is the 4Y. Yes, 4Y signal. So we need to isolate, convert from 2Y because the transmitter is 2Y. So we need convert to 4Y. Okay. Terminal number 5 and number 6 is 4Y signal that we can connect to the analog input module. Okay. So this is just example about how to wiring, and we can follow me if we would like to use the EM235 with the thermocouple. So we need to use one more for temperature transmitter. Okay. And I will use the connector and the step 7 microwin version 4 CV page 9 to test for example for easy to understand. Okay. And I will use the connector PC adapter USB A2 for online. When we adjust or we hit the thermocouple, we will see the temperature is increased. Okay. So I will detail more for this drawing of this one. Yes, so let's go with me. Okay, here is the detail of drawing and switch for selection. So here is the power supply 220 volt AC. I connect here, and then I will connect plus and minus of 24 voltage DC to supply the EM module. And here is the resistance for adjustment for calibration. Example, the value here is over or under a little bit, so we can adjust. Yeah. Here is the data that I test with the current loop standard source. Yeah. So when I adjust 0 milliamp, I will got from 0 to 200, 4 milliamp here, 8 milliamp here, until 20 milliamp here, 32,760. Okay. So here is the deep switch for select the function. I will detail more on the manual operation of this module, EM235. And here is the isolator that convert from signal 2Y to 4Y. So there are 6 terminals that we will use. So for terminal number 2 and number 3, if we supply the voltage to terminal number 9 and number 10, we will got 20 volt for terminal number 2 and number 3. And number 3 is plus, number 2 is minus. So we can connect from this one to the temperature transmitter. Yeah. And then the temperature transmitter, there are 2 terminals more for connect to the thermocouple. And this one is millivolt, so it has plus and minus also. So plus connect to plus, minus connect to minus of transmitter. Okay. And then we will got the signal for 220 milliamp from the terminal number 5 and number 6. Yes. And then we will connect to the analog input module. And please follow this deep switch, otherwise it will not work. Okay. So this is a signal that I test. So next we will convert from the scaling for to 20 milliamp, right? Because our PLC is just 0 to 20 milliamp, this terminal. Yes. So we need to convert. I will show in the next step. So let's go to our slide again. I will show. So here is the detail of isolator that we can convert from 2Y signal to 4Y signal. Yeah. And here is the brand. Yeah. And this is the electrical diagram, so we can follow. We have many functions that we can use. Yes. That's okay. So we will go to our software if everyone understand about how to wiring. Yes, because it's very important for wiring. Yes. So let's go to test the signal with step 7 microwin with me. Yes. But before go to our software of step 7 microwin, I would like to explain why we use the deep switch. Yeah. We have manual operation. Yeah. So we can read for this module. Yeah. And this module. If we choose 231 analog input, we can follow this module operation. And if we choose the 253 analog input, we can use the follow this drawing. Okay. So here is the manual operation. Then we can see the signal here. Right now I choose this one, on, off, 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 and on, because I will use signal from 0 to 20 milliamp. Okay. So we can read the manual operation from the file of this module specification, and then we can follow. Okay. So right now we already understand about how to wiring and how to use the deep switch for selection the signal of this analog. So next we will go to step 7 microwin. So let's open step 7 microwin program. And then we will convert from signal from 4 to 20 milliamp, right? To 0 to 20 milliamp. Yes. Because our PLC is 0 to 20 milliamp. Yes. Here. 0 to 20 milliamp. So we need to use the scale, right? For scale, if we have the library that I already explained and create it on the previous video. Yeah, follow our drawing here. We have output equal input minus low scale input multiplied by high scale output minus low scale output divided by high scale input minus low scale input and plus low scale output. So we will got output. Okay, and here is the simulation that I already created. Yes, so if the data here, let's see the data here, 4 milliamp is 6550, right? So I will put 6550 here. Yeah, it is the low scale in, and for the maximum it is the high scale in, right? So high scale in is 32,760. So I will put here. Yes, then if the input and then the range of temperature is 0 to 100 degrees Celsius, right? So if the input is show 6550, the temperature will show 0 degrees Celsius. Yes, if the input show around 16,000, yeah, it will show around 36.05 degrees Celsius. Okay, so it is the input from analog input, example AIW0, and here is the high scale raw data. Yeah, raw data high. Yeah, it means that the maximum when we put the 20 milliamp here. Yeah, 20 milliamp, and here is the raw data loss, 4 milliamp. Yeah, and here is the scale of transmitter, high scale of transmitter, temperature transmitter. Yeah, and here is the low scale of temperature transmitter, and we will got the output. Okay, so when the analog that provide from the transmitter and then connect to the analog input, it will show like this. Okay, so if we would like to create the scale, we can follow me by using the formula. We will got the actual value of temperature transmitter. So I will show again about how to create the scale. Yeah, so we can copy this command to our software. Okay, go here and then we can paste here. This one low scale, right? Low scale in, input minus low scale in. Yes, so input minus low scale input. Yes, so first we need to create the parameter, right? Okay, I will put the same as the format, so the capital letter, right? So input minus low scale input. Okay, this one. let's see here, input minus low scale input. Okay, then we need to provide or declare the parameter, right? So first is the input we can put here. Yeah, actually I already created in the previous video. Yeah, so we can import or use it, but right now I will explain again about how to create it. So we can also create the library of scale. Yeah, so first is the input, so I will put input here. So input, and the data type is integer, right? Because we will got from the analog input. So I will put integer, and here is the command. So we can command as input value from analog input, and next we will create the high scale, right? High scale input. So high scale in, and high scale in I will use real for data type. So high scale input, and then low scale input, right? This one, low scale in. Actually we can copy from here. Yeah, for high scale input example, this one we can copy here from my command. Yeah, and then paste. And for low scale input, you can copy here. Yes, and the data type is real also. And for the command, we can command as low scale input, and we need to put the high scale output, right? So high scale output we can copy here. So we can create the library with our own program that we want. Next time if we use this block, we can drag and drop, just drag and drop to use. Yeah, easy, no need to create again. So this one is high scale output. Yes, and next we need to create the low scale output, right? So low scale output here, data type will put real also. Yes, and for this one we can also put real. Yeah, then we can convert on the program, the main program. When we drag and drop to you, we can also use real. Yes, so I will put real. And low scale output, so we can command low scale output. Yes, and so for output we have only one, right? So output we can copy from here. If we know the concept, we can create the library. Yes, real also. So this one is the output. Okay, and we will follow our formula, right? So first I will use the always on, right? SM0.0, and then I will use the input minus low scale in, right? So input minus low scale in, so I will use the subtract, right? Subreal here. So input we can use we can copy here, input, copy, Control V, yes, and minus low scale input, right? So low scale input we can copy here, and we will create the temporary variables to here, yeah. Example, temp1, it is the real, right, data type, because it is the output here. So we can copy temp1 here, because we cannot use the actual variable, yeah, in this section subroutine, yes. So next we will go to high scale minus low scale, right? High scale out minus low scale out. So we can use subtract also, subreal. Can use subreal, and we can connect like this. Use arrow key and control to connect the wire. So high scale out minus low scale out, right? So high scale out here minus low scale out. So we can copy and paste here, and we will create one more temp. Example temp2. The data type is real also, yes. So I will got temp2 here, so we can copy and paste. And the next step we can go to high scale in minus low scale in, right? High scale input minus low scale input. So here we can also use subreal, sub between high scale in minus low scale in, right? So high scale in, this is a high scale in, yes. So copy and paste here, minus low scale in, right? Minus low scale in, so we can copy low scale in, and then I will create one more temp. Example temp3, it is the real also, yes. So I will copy temp3 from here and paste here, yes. And then we need to multiply between this one, temp1 and temp2, right? So multiply, we can use multiply real. Yes, multiply real between temp1 and temp2, right? Here temp1 and here is temp2, so we can copy here with the temp2, can copy here, and then we can use control and arrow key to connect the wire. And I will create one more for temp4. The data is real also, so this one should be temp4, right? And then I will use this one, yes, one more, right? So this one is temp3, so temp3 divided by temp4, right? Sorry, temp4 divided by temp3. So I will use divide real between temp4 with the temp3, right? This one temp3, so this one, and then I will create one more temp. Example temp5, it is the real also for data type. So temp5 plus low scale out, right? So this one should be temp5. And then temp5 plus by low scale output, right? So I will use add real. Yes. So temp5 plus low scale out, right? So low scale out, which one? This one, low scale out. Okay. And then I will got output. Okay. So output here. Okay. So right now we already create the library for scale, and then here we can comment created by general technology knowledge. Yes. Okay. And then we can compile. Yes. Let's see, no error, right? Okay. So here we can rename the subroutine as scaling. Yeah, example scaling. And if we would like to use it, let's go to call on main program, and then go to call subroutine, drag and drop here. So we will got the scale that we already created. Okay. So I will insert the column, insert the row. So first let use SM0.0, and I will convert from the analog input to the real, right? So let's go to integer to double integer, because we need to convert to real, right? So here integer to double integer. Then here is the AIW0. Yes, AIW0 here. Yeah, it is the address of analog input. So I will put AIW0, and I will create the temporary variable, example var1. The data is double integer, right? So the int here, double integer. So here I can put var1, and then we will convert from double integer to real, right? Because the input that we declare is the real. Okay. So convert from di to real. Okay, then convert this one to real. So I will create one more for var2. It is the real, right? So I will put var2 here. Okay. Then we can connect with this one. Yes. And I will copy the var2 here, because it is the input that we convert from the analog input. And for this one, we need to follow the data that we already tested. So the high scale input is here, right? High scale input 20 milliamp, 32,760. So 32,660.0, because it is the real. And for milliamp is 6550, right? So 6550.0, and here is the temperature transmitter rank. So my temperature is 0 to 100 degrees Celsius. So I will put 100.0, and this one 0.0, and we will assign the memory to show. Example VD 100. Yes. So we will compile, and then we can download. Yeah. Before download, let me connect the connector PC adapter A2, yes, to my PC, and then let's check the communication. Yeah. First, go to set the PC PG interface, and then choose the driver PC adapter A2 here. Go to property, make sure we check box here. PC is only master on bus, and then choose the transmission rate 9.6 kilobyte per sec, and choose DP, and click OK, and then OK again, and go to the communication, and then double click here to refresh between our PC connector with the PLC. So it will found the CPU. So right now I use CPU 222. Yes, so it will detect, and then we can save. Before download, we can save our project. Example scale Thermocouple. Okay, and then we can download. Okay, I will stop the CPU, and then run the CPU after download. Okay, so right now let's see the temperature. It show around 16 degrees Celsius. Yeah, so I will hit the thermocouple to let everyone see the status. Okay, let's see here. The milliamp is show around 6 milliamp. Yes. So I will hit the temperature, hit the thermocouple. Let's see the temperature, the milliamp is increased, and the PLC online is increased also. Yes. I hit more. Yeah, right now around 12 milliamp. So it show around 51 degrees Celsius. Okay, I will hit more. Yes, hit more. Yes, the temperature is increased around 60 degrees Celsius. Yeah, so it works properly. So here is my transmitter, and here is the isolator that connect with PLC. Okay, so it works. So this is just instruction about how to connect and create the scaling for analog input module EM235 that connect with the thermocouple. Okay, so if we have this scaling library, so basically we can export and import to use next time. Okay, I will show. So right now I save the project first. So if we would like to use this library with the other project, we can also right click and then export. Example, I export keep on desktop, and the folder name should be scale AI, and this one example scale AI also. So when we go to see the folder, scale AI folder, we will got this file, right? We will got this file. So if everyone would like to use with other project, example I save this one first. Okay, the blank project will got only like this, right? So we can open and then go to subroutine here, and then we can right click and then import the scale that we already created. Yeah, so we no need to create it again. So go to this folder and then click here. We will got the scaling, and then we can go to the main program and then call this one to use. Okay, so we will got this one. Okay, I will drop the link for download of this library under my video. Okay, easy to understand. So if everyone would like to see the how to scaling this one, please download my file to use or to read. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new video that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye.